Hi, everybody. So my name is Bartek, and today I wanted to talk a little bit about Git and the features that you might not know about. I guess a lot of you know that there are a lot of commands in Git and how you can use it. And I feel like most people kind of know 4, and that's all they use, which is totally fine. But there are cases where you would like to make either the history a little bit cleaner or do some strange stuff. So I'm Bartek. I work at Craft. We do this kind of software as well. This is all Craft. You can see here. Maybe not all around this cursor. So yeah, straight into it. I wanted to do it fairly quickly. So the first one is git work tree. That's a command that's super useful right now, especially in the all AI world, because it allows you to kind of clone the whole repo to a different folder and be able to have like 2 simultaneous code bases working at the same time. So let me quickly showcase it to you. So if you do git work tree and then go for add, you can specify a work tree folder and then a branch. So branch for me. And now you can see that there has been a new branch and there's now a commit here. So when you go to this folder, you have this branch now. The whole repo got cloned. You didn't have to do clone again. Also, the .git folder is being shared now, so all of the history is here. So if you want to spin up a second Cloud Code instance somewhere in the background, this is super nice. At the same time, if you go into, I don't know, Cursor or any other editor, I'm not sure where is it when it's so small. Okay. Where is it? 1, 2. No. Oh yeah, here. So even in the source control tab here, in the sidebar, you can see all of the work trees here as well. So you can quickly jump between them and create history. So yeah, so that one is super nice. I use it every day now, especially with a lot of AI work. The second one is bisect, which is really underappreciated, I think, because it helps you find bugs super quickly, or more where the bugs are coming from. So in here, in this repo, I've got a bunch of commits, and I hope at work you've got even more. So the idea here is that I've got a new test that I've just written, which is demo and test factorial, and it fails. And I know this function worked before. So what can I do to find it? So I can go every commit one by one, start finding it, but it will take a lot of time. And as some of you may know from computer science classes, one of the fastest ways to search for things in a sorted list. So git history in commits is basically a sorted list of the changes that you have. And the thing that is there is binary search. So how it works is that you go, you take the whole data set and try to half it and then compare if the value that you are looking for is smaller or bigger, and then if it's bigger, then you take the right side, and then half it and half it and half it and half it, and basically you go from n operations to logarithm of n, which is much smaller, and we can do the same thing in Git. So if I go here and do git bisect start, which basically starts the whole process, you can see that it even says that We're now waiting for both good and bad commits. So these are the commands that we want to use, and we know that this one is bad, so git bisect bad. And we know that at version 1.0, it was working, so we're saying that git bisect good. And now you can see that it's saying here 6 revisions left to test. So basically, it got us in the middle, and now we have to check if the test is still failing or not. It is failing, so we should say that it is bad. And now it halved it even more, and there are here 3 revisions left. What we also can do is use git bisect run, which will do a bunch of things automatically for us. So I can even plug this test into it, and when I run it, it was super quick because it's a super easy test, but it actually went through all of those steps automatically for me, running test every time, and if the tests passed, it treated it as a good commit, and if it failed, as a bad commit. And now you can see that out of all of those commits, it's saying that this one is the first bad commit, and of course, it's a refactor. So if I do git show and show this commit, then yeah, that was the culprit. So it's super easy to find where the bugs actually started. So yeah, so that's bisect, and you can then git bisect reset and go back to where you were before. The next one is git rebase, which actually this one you might know, but the flag called onto, which gives you an option to kind of put stuff onto another branch. I think it will be the easiest to just show you as an example, and that's actually something that when I'm using all the time, because I tend to forget to change branches. So let's say I go to a branch called feature A, and then I create a folder here, and then do some changes. And then now I commit, and I'm happy. I create a pull request now, usually, but I know I've got some more stuff to do. So I want to add another feature called rate limit. And now I go ahead and commit the rate limit. And then, oh shoot, I am on the wrong branch. And if I want to create a pull request out of this commit that I have right now, I will create a pull request for both of those commits that I have just made. And previously, what I was doing is I was doing git reset and doing git reset hard origin main, and then cherry picking stuff from the history. So basically, setting it to main and then putting manually all of the commits I wanted to have on this particular branch. So so to do it differently, I can go to, for example, feature B now, and I can do git rebase onto master, and then do head, and this till the after head is basically go back once. So what this will do is we'll take master and take all of the commits from head and one before and put it onto master. So if you've got more, it's main. So now if you go into git log and see the history, then basically it's just this one commit over here instead of 2 ones as it was here. So it's just much cleaner to create pull requests this way, and if you work on multiple stuff at the same time, like I do tend to forget to change branches. So if you do, it's just less work to do. Yeah. So the next one is git nodes, which actually I've learned when I was kind of preparing to this talk. So nodes might seem like a stupid idea. We've got commit messages already. But the problem with commit messages is that they are actually a part of each commit. So if you change the message of the commit, the whole commit changes. So if you've got CI set up, where you deploy, for example, on every push, if you want to add a message about like when was this commit deployed, when you make a change to the commit, you have to push, and then the commit changed, so you trigger the whole workflow of deployment, which isn't great, and you go basically into an infinite loop. And nodes are a thing that can help you with it. So they are separate from the commits themselves. So when you add a node to a commit, so it's not that decoupled, but you can add a node to a commit. When you add a node to a commit, it's not changing the commit itself. So no, I'm still working. Yeah, so if I go to git log show notes, when I scroll, you can see that, for example, here I've got a note that this commit was deployed at that time. And basically it's just a message attached to a commit. But what is nice is that like you can use it anytime you want for, like, I think this is the best scenario for it. Like if you want to attach that this commit was deployed at this time and you want to have it in the history somehow without changing anything in the CI, this is a super cool way to do it. But the only caveat is that when you do a push or pull, you have to also specify explicitly that you want to pull or push the commit, the nodes. And yeah, the next one is sparse checkout. So this one is probably not useful all the time, or rather you really have to have a use case for it to be there, but at the same time, it happened for me, so that's why I'm talking about it. Sometimes it happens that you've got a really, really big repo. Like I've got one, not here, this one, not this one. So that's a repo that like has 7 gigs of data in it, which takes a lot of time to download. But at the same time, I wanted to automate it, so have some GitHub actions running on it. But I still didn't want to have the whole thing like being downloaded. And when you actually have a look at the action, it took 25 seconds to run everything that I wanted. And how do I do it? There's the thing called sparse checkout. So what you can do is, let me get a script because there's a lot of things to do. Oh, not that one, that one. You can do like this is a little bit of a setup. And let me just run it. Okay. Oh shit. No, I initially, okay. Okay. Okay, and now it should work. So now I've initialized an empty repo, and if I ls here, there are basically no files here, but the repo itself is already attached. And what I can do now is use the sparse checkout command. So if I run this one, so is sparse checkout set, and then I specify a bunch of files or folders. If I run it and then run the second one, you can find it on the internet how to use it. It will fetch only those few certain files that we wanted. So it doesn't download all of the repo, and you can just get a few files that you really need. So for example, for me, it was deployment of for Cloudflare, so I need the Wrangler and the headers. And there's also a command that kind of is connected to, which is git ls3. So so even if you don't download the whole repo, you can still check out what are the files in the repo, even though they are not physically on the disk. So you can also do stuff with it. I'm also generating like a JSON of a tree of the files. So if you've got a really big repo, that's really useful. You can also do the same thing if you've got a monorepo with a bunch of different sub-modules or sub-projects, and only download the ones that you really need. So you don't really have to care, for example, about the backend theme changes. You just care about what you are doing. Yep. And then there are like two last ones, which is git archive and git bundle, which are commands to export your repo. So if you do git archive, and it's git archive, and then you do the format, which could be zip, and output file.zip, and then you do head, or let's do master main. It created a zip file with basically the whole repo wrapped into it, but it removed all of the files from gitignore, and it removed all of the .git files. So basically, if you really want to share a project with somebody quickly without like all of the git overhead, you can do it with one command without deleting all of the files manually. And then the other one is git bundle, which kind of serves a similar purpose, where you create a bundle, and it's a file that will store everything from Git into this one file. So that's basically the whole repo. It's more or less like you would do zip on everything, but it also strips all of the files from gitignore, and then you can also do git clone and specify this file. And then you've got a repo based on that. And yeah, you can see that there's, for example, .demo, which is in the gitignore, isn't in here. Yeah, and I guess that's it. Those were the commands, and I'm kind of also curious who have used all of them. Okay, 6 of them. 5. Okay, 4. 3. 2. And 1. Nice, nice. All right, that's it from me then. Thank you so much. If you want to see those commands, they are on the first link, and the rest is me on GitHub X and whatnot. And if you've got any questions or any other Git commands that you want to share.
Thank you for your talk. To be honest, I don't remember the name of command. I guess maybe you can tell for the audience. But for me also was very useful. I don't remember because I used it only once. One command, then when you clone in the repository, you can clone only files without the history and commit messages. Because, for example, in my case, in my repository, there is about up to a few gigabytes of the source code and more than 100 gigabytes of the commit messages because we're using Gerrit, etc. So maybe you can remind me, for example.
It's still git clone, but I think it's either, I don't remember which one, but I think it's either of those flags. I think depth one is downloading only the top commit from the branch. So I think that's it. There's like git clone has a lot of different flags, and it can,
Okay, thank you. It was very interesting.
Thanks.